Modern concrete is dying. Right now, bridges across America are crumbling, buildings are being condemned, and engineers are scrambling to replace structures that are barely 50 years old. But 2,000 years ago, Roman engineers built harbors that have been battered by ocean waves for 20 centuries and they are still standing. The Pantheon's concrete dome has survived earthquakes that leveled entire cities. For decades, scientists assumed the Romans were just lucky. They were wrong. In 2017, researchers at MIT made a discovery that shocked the engineering world. Roman concrete doesn't just resist damage. It actually heals itself. And the secret ingredient? It was right in front of us the entire time. Here's what makes this mystery so baffling. Modern concrete is engineered with precise chemical formulas, controlled temperatures, and steel reinforcement. We have supercomputers modeling stress points and PhD chemists optimizing every ingredient. Yet our concrete starts degrading the moment it's poured. Roman concrete, mixed by hand, using materials they barely understood, with no steel reinforcement whatsoever. And it just keeps getting stronger. The question that haunted researchers for over a century was simple: what did the Romans know that we forgot? But here's where it gets strange. When scientists first analyzed Roman concrete in the 1970s, they found the recipe. Volcanic ash, lime, seawater, and rock. They published their findings. Case closed, right? Pause twos, except when modern engineers tried to recreate it using the exact same ingredients, their concrete crumbled just like everything else. Something was missing. Something the Romans never wrote down. To understand why this matters, you need to see where Roman concrete has survived. The harbor at Caesarea Maritima was built by King Herod around 25 BCE. For over 2,000 years, it has been submerged in corrosive Mediterranean seawater, battered by storms, and shaken by earthquakes. Modern marine concrete barely lasts 50 years in similar conditions. The Roman structure. Engineers recently surveyed it and found it's actually harder now than when it was built. SFX, dramatic sound. Then there's the Pantheon in Rome. Its dome spans 143 feet and remains the largest unreinforced concrete dome ever constructed. That record has stood for nearly 2 millennia. Every attempt to build an unreinforced dome this large with modern concrete has failed. And the Roman aqueducts? Some still carry water today. If this is blowing your mind, drop a like because we're just getting started. The Romans weren't just good builders. They accidentally created something that defies everything modern material science predicted was possible. Tone shift, analytical to dramatic. Now imagine you're a Roman engineer standing on the shores of the Bay of Naples around 100 BC. Behind you sits Mount Vesuvius, not yet famous for destroying Pompeii. At your feet lies a strange powdery substance the locals call pulvis pudialinus, ash from the volcanic fields of Pozzuolo. You don't understand chemistry. You don't know what silicon dioxide is. But you've noticed something extraordinary. When you mix this volcanic ash with lime and seawater, then pack it into wooden forms underwater, something magical happens. The mixture doesn't dissolve. It doesn't wash away. It turns to stone. The Romans had stumbled onto something that would take modern science 2,000 years to explain. They called it opus caementitium. We call it the greatest accidental discovery in construction history. But the real question isn't what they found. It's why it works when nothing else does. The first clue came from studying Roman harbor concrete at the molecular level. In 2012, geologist Marie Jackson led a team that examined samples from ancient Roman breakwaters. What they found under electron microscopes changed everything. Modern Portland cement concrete works through a simple chemical reaction. You mix cement with water, it forms calcium silicate hydrate crystite, it hardens, and that's it. The reaction is finished. The concrete will only get weaker from that point forward as water and salt slowly break it down. But Roman concrete showed something unprecedented. The volcanic ash wasn't just filling space. It was actively reacting with the seawater to form new minerals. Crystals of aluminous tobermorite and philipsite were growing inside the concrete. Let me repeat that. Growing. The material wasn't static. It was evolving. For the first time, scientists had evidence that Roman concrete was fundamentally different from anything we build today. But that discovery was just the beginning. Because what happened next turned this archaeological curiosity into one of the most important materials science breakthroughs of our century. SFX, dramatic sound. In 2017, MIT researchers led by Admir Mazik made a discovery that everyone had missed. For decades, scientists assumed that white chunks in Roman concrete were a defect, evidence of sloppy mixing where the quickite, the calcium oxide, hadn't fully incorporated. Mazik's team looked closer. Those white chunks weren't mistakes. They were the key to everything. Here's what nobody expected. When Roman concrete develops a crack, moisture seeps in and reaches these calcium-rich chunks. The calcium dissolves, flows into the crack, and recrystallizes, literally healing the damage. Pause 2's, Roman concrete doesn't just resist cracking. It fixes itself. If you want to see how this changes everything, make sure you're subscribed because this story is far from over. The Romans hadn't just built strong concrete. They had accidentally invented a self-healing material that modern engineers are still struggling to replicate. Perspective shift, so here's the million-dollar question. If we know the recipe and we understand the chemistry, why aren't we building everything with Roman-style concrete right now? Pause 2's, the answer reveals something uncomfortable about modern civilization. Roman concrete takes years to reach full strength. Modern construction can't wait years. We need buildings up in months. Roman concrete requires specific volcanic ash that only exists in certain locations. Shipping it globally would be enormously expensive. And our entire construction industry, every building code, every engineering degree, every piece of equipment, is designed around Portland cement. Changing would cost trillions. But here's what most people miss. The calculus is changing. Tell me in the comments, did you know this next part? Our concrete infrastructure produces 8% of global carbon dioxide emissions. 8%. More than aviation and shipping combined. Roman concrete production generated a fraction of those emissions. Suddenly, an ancient recipe isn't just historically interesting. It might be environmentally essential. And this brings us to what scientists call the most exciting development in concrete technology in over a century. Direct address, pay attention to this part because this is the breakthrough that changes everything. In 2023, the MIT team successfully created modern self-healing concrete using the Roman principles. They developed a technique called hot mixing, where quickite is mixed at higher temperatures, creating those same calcium-rich chunks that give Roman concrete its self-healing properties. The early tests are remarkable. Cracks that would permanently damage standard concrete sealed themselves within 2 weeks. 2 weeks. And here's the revelation that closes the loop we opened at the beginning. Remember how the original Roman recipe couldn't be replicated? Scientists weren't failing because they had the wrong ingredients. They were failing because they didn't understand the process. The Romans weren't just mixing ash and lime. They were mixing them in a specific way, at specific temperatures, that created those crucial imperfections. What looked like sloppy ancient craftsmanship was actually the most sophisticated self-healing technology the world had ever seen. 2,000 years ago, Roman engineers stood at the edge of the Mediterranean and solved a problem we're only now beginning to understand. They didn't have electron microscopes or chemistry degrees. They had observation, patience, and generations of accumulated wisdom passed down from master to apprentice. And somewhere along the way, that knowledge was lost. Not destroyed. Not hidden. Just forgotten, dismissed as primitive by civilizations convinced they knew better. The Pantheon still stands as a testament to what they achieved. Not a ruin. Not a curiosity. A fully functional building, still holding the record for the largest unreinforced concrete dome on Earth, still teaching us lessons we weren't humble enough to learn. What else did ancient civilizations know that we've forgotten? What other lost knowledge is waiting to be rediscovered? If this story made you see the past differently, explore more ancient mysteries with the video on screen now. And drop a comment telling me what ancient technology you think deserves investigation next. Because sometimes the greatest innovations aren't ahead of us. They're buried beneath 2,000 years of assumptions. But before you go, there's one more piece to this puzzle that changes the entire picture. The researchers at MIT aren't just recreating Roman concrete for academic papers. Major construction companies are now licensing this technology. By 2030, we could see the first commercial buildings using self-healing concrete inspired by 2,000-year-old Roman recipes. Imagine infrastructure that repairs itself. Bridges that seal their own cracks. Sea walls that get stronger with every storm. The Romans built an empire that lasted 1,000 years partly because their concrete outlasted everything around it. We're now standing at the threshold of doing the same thing, not by inventing something new, but by finally understanding something ancient. And here's what makes this story so remarkable. For over a century, we looked at Roman ruins and saw primitive construction. We saw sloppy mixing and chunky lime and assumed we were better. It took electron microscopes and molecular analysis to prove that what looked like weakness was actually genius we couldn't recognize. Music shift, let's put the full picture together. The Roman concrete mystery wasn't just about chemistry. It was about humility. For decades, scientists looked at an ancient material that outperformed everything we could build and assumed there must be a simple explanation. There wasn't. The volcanic ash from Pozzuoli creates a pozzolanic reaction with lime and seawater that generates new mineral growth over centuries. The lime clasts that look like mixing errors are actually calcium reservoirs that enable self-healing when cracks form. The seawater that would destroy modern concrete actually strengthens Roman marine structures through ongoing mineralization. Every detail that seemed like a flaw was actually a feature. And the Romans discovered all of this through nothing more than careful observation and trial and error across generations. They couldn't explain why it worked. They just knew that it did. And they built wonders that still stand. And this is perhaps the most important lesson Roman concrete teaches us. Progress isn't always linear. Sometimes the answers to our most pressing modern challenges are hiding in the past, waiting for us to be humble enough to look. The climate crisis demands we rethink how we build. Roman concrete offers a blueprint. Our crumbling infrastructure needs materials that last. Roman concrete provides proof it's possible. Our assumption that newer always means better has cost us decades of innovation we could have learned from ancient wisdom. Pause 2,000 years ago, a Roman engineer mixed volcanic ash, lime, and seawater in a wooden form and created a material that would outlast empires. Today, scientists in laboratories around the world are finally understanding why. And tomorrow, buildings might heal themselves because we finally listened to what the ancients have been trying to tell us all along. The knowledge was never lost. We just stopped looking. Now you understand the Roman concrete mystery. Not just what it is, but why it matters. 2,000 years of accumulated wisdom, dismissed as primitive, is now revolutionizing modern materials science. If this changed how you see ancient engineering, share it with someone who thinks older always means worse. Subscribe for more investigations into lost knowledge and forgotten technology. And tell me in the comments, what ancient innovation do you think we should explore next? Because the past has more to teach us than we ever imagined. And we're just getting started.